Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, dear students. Today, inshallah, we'll talk about the second lesson in topic 1 for IGCSE Physics, which is about motion. Inshallah, in this video, we'll talk about speed, velocity, and acceleration. Let's start. If I have a question like this about a rabbit and a turtle, they are here in these positions after 40 seconds from the start. And you are asked about which one is faster. Look at this. If we want to talk about which one is faster here, we have to think about the distance and time. The distance covered by the object and the time taken to cover this distance. Again, to say which one is faster, we have to think about the distance covered or the distance traveled and the time taken to travel this distance. For example, here, the rabbit covers longer distance, so the rabbit is faster. Again, why? Because it covers longer distance in the same time. Good. What if they cover the same distance? Here, longer distance, it's okay in the same time. What if they cover the same distance? In this case, the shorter the time means the faster the object. Okay, so again, to say which one is faster, we have to think about the distance and time. What is the concept that relates distance and time? When we talk about distance and time, the concept which relates them, which links them, is speed. So the speed is the distance covered. The speed is the distance covered in unit time, or the distance traveled in unit time. Okay, so to calculate the average speed, we divide the total distance traveled by the time taken to cover or to travel this distance. Again, the speed is distance divided by time. So the longer the distance for the same time, the faster the object is, the higher the speed. The shorter the time, the higher the speed for the same distance. So v, which is the speed, equals distance s over time t. We can put this in a triangle like this. So the average speed equals total distance over total time. Good. What is the SI unit of distance? Distance is a length. So the SI unit of distance is meter. What is the SI unit of time? Of course, it is second. So what is the unit of the speed? It is meter here per second. So if the distance is covered in meters or measured in meters, the time is measured in seconds. So the speed is measured in meters per second. Understood? Good. Now we talked about speed. What about the velocity? Are they the same? Or there's a difference between them? Yes, I know that. We talked about this in vectors and scalars, and we said that speed is a scalar and the velocity is a vector quantity. So the velocity has a direction, but the speed has no direction. We can say that the velocity is the speed plus a direction. So the velocity is the speed in a given direction. Okay, for example, here, I have the speed equals 20 meters per second. It's okay. This is the magnitude, 20 meters per second, because it is a scalar, so it has here only a magnitude. What about the velocity? The velocity has both a magnitude which is equal to the speed here, if we are talking about the same object, plus the direction. So the velocity has a direction here. Here, this car is traveling to the west, and this car is traveling to the east. The speed here is 15 meters per second, and the speed here is also 15 meters per second. So the speed is the same because the speed does not have a direction. What about the velocity? The velocity here is different from the velocity here. The velocity here is to the west, but the velocity here is to the east. So the velocity here is different from the velocity in the second case. Good. Let's try to answer this question. Please, you can pause the video and answer the question. Okay. What is required here? We need to calculate the average speed. Good. The average speed equals total distance over total time. Are they given here? This is 100-meter Olympic sprint. This is the total distance. And the time here is 9.58. So the speed equals 100 meters over 9.58 seconds. So the speed equals 10.4 meter per second. Look here. We have another question. The speed is given in the speedometer here. But we need this speed in meter per hour and in meter per second. The speed is given here in kilometer per hour. How to convert from kilometer per hour to meter per hour? It's very easy. What is the speed here? The speed here is 120 kilometer per hour. We want to get it in meter per hour. Meter per hour. So the hour is the same, but we have here kilometer. We want to convert it to meter. It's very simple. We will remove kilo and we'll put its value, which is 1,000. Very simple. So it will be 120 times 1,000 meter per hour. So it will be 1.2 times 10 power 5 meter per hour. Very easy. Okay, what about the second question? They need it in meter per second. Good. Meter, we want to convert this to be meter per second. This one is 1.2 times 10 power 5 hour. Meter per hour means meter divided by hour. Now it is easy. Meter is the same, so we'll not do any change here. We'll talk about the hour and how to convert the hour to seconds. Look at this. It will be 1.2 times 10 power 5. No change here because meter is the same. Over the hour. How to convert an hour to seconds? 1 hour equals 60 minutes, and each minute equals 60 seconds. So from this, we can get it very easy. Okay, look at this here. It is easy here, 1.2 times 10 power 5. And in this case, this one equals 33.3 meter per second. Okay, look at this, pause it, and try to get the answer. I will show the answer after a while. Have you answered it like this? What if we want to convert it to meter per second, we will multiply by 1000 up because we are converting kilometer to meter. So it equals 90 kilometer per hour equals. This one will be meter per second. So it equals. This one is 90. We will remove kilo. Kilo means 1000 over. This is hour. We want to convert it to seconds. So it is 60 minutes times 60 seconds. Finish. Finish. Very simple. Now we are going to talk about the acceleration. You know that I think, when we want to accelerate anything, this means we are changing its velocity or its speed. Okay, what is the acceleration in physics? The acceleration in physics is the rate at which the velocity changes. Or you can say that the change in velocity per unit time. So to have acceleration, please look at this. The velocity must change. If the velocity changes, we have acceleration. Acceleration exists when the velocity changes. The velocity is a vector, of course, so it has both magnitude and direction. So if one of them or both change, this means we have acceleration. But in this lesson, we'll talk about only the change in magnitude. So we'll see if the object speeds up or slows down. So if the object speeds up, increases its speed, or slows down, decreases its speed, acceleration exists. Acceleration is the rate. Acceleration A is the rate means delta t, at which the velocity changes. Delta here with the velocity means the change n. Delta is a Greek letter which is used here to represent the change n. So here, and delta t means the change in time, or you can say it time interval, or the time taken to make this a change. So the time taken to make this a change is delta t, or the time interval. Again, the acceleration equals the change in velocity over the time interval. It equals delta v over delta t. How to get the change in anything? The change in anything equals the final minus the initial. The final velocity here will be represented using v, and the initial velocity will be used here, or will be represented here by u. So that change in velocity equals the final velocity v minus the initial velocity u. Good. What is the unit of acceleration? What is the unit of acceleration? From this equation, the speed or the velocity, the unit is meter per second. Both of them have the same unit, speed and velocity. The time has the unit second. So the SI unit of acceleration is meter per second per second, or second second. This means the unit of acceleration is meter per second squared. Good? Yes, of course. The SI unit of acceleration is meter per second squared. So if the object slows down, the acceleration will be called deceleration. So what is the difference between acceleration and deceleration? Acceleration is general, but if we want to talk about the deceleration, it means the acceleration with a negative sign. Okay, so the deceleration, the same thing. If we are calculating the acceleration, we calculate the deceleration using this. Don't forget this. A equals delta V, change in velocity over time. In this case, we'll get the final velocity minus the initial velocity over the time interval. So whatever the acceleration, if it is positive acceleration or negative acceleration, which is deceleration, we'll use this. The same unit, of course, meter per second square. The only difference is the deceleration has a negative sign. Okay, let's try to answer this question. A car changes speed from 15 meter per second to 25 meter per second in 2.5 seconds. Calculate the acceleration. In this case, we are asked to calculate the acceleration. Acceleration again and again equals delta V over delta T. It equals the final velocity minus the initial velocity over delta T. What are the givens here? They said that speed changes speed from mean this is the initial speed to this is the final speed. In 2.5 seconds, this is the time interval. Now we can get the acceleration. So the acceleration here equals delta V, which is, delta V, which is V minus U, which is 25 minus 15 over the time, which is 2.5. 25 minus 15 is 10 over 2.5 means positive 4 meter per second squared. Yes, very good. Because this is in meter per second and this is in second. So it is meter per second squared. Brilliant. This is the answer here. What if the car changes its speed from 25 to 15? So this will be U, this will be V in the same time, which is 2.5. Try to answer it. Of course, yes. It will be the same acceleration, but with a negative sign. Very good. Let's answer this question. A car passes point A with a velocity of 10 meters per second. It has a steady or constant acceleration of 4 meters per second squared. What is the velocity when it passes point B? So it is moving from A, so this is the initial velocity, to B, so this is the final velocity. We need the final velocity. The initial velocity here is at A is 10 meters per second. The acceleration is 4 meters per second squared, and the time is given here in the figure, which is 6 seconds. Good. What is the velocity when it passes point B? This means we need the final velocity. Try to get the answer and pause the video to get the answer. Acceleration equals the final velocity minus the initial velocity over the time. Let's see the answer. Okay. And from this, A is given, U is given, T is given. We need to get V. So from this, we will make cross multiplying. So it will be V minus U equals A delta T. Good. All of them are given, or V equals 10 plus 4 times 6. This means V equals 34 meters per second. Understood? Good. Look at these questions. And we have here 4 questions. You can pause the video and try to answer them. And the answers will be at the end here. These are the answers. If you don't understand any of these questions, please write in the comments. Thank you very much. This is the end of this lesson. Assalamu alaikum wa rahmatullahi wa barakatuh.